Hey everyone, today we're going to be doing a review of the basic derivative rules. Now, before we begin, in this video I'm going to be running through some example problems for the derivatives that I'm talking about. So if at any point you need to pause the video and write stuff down or go through the problems by yourself, that's perfectly fine because the goal of this video is to just get people comfortable with the concepts of basic derivative rules. Also, what I did was I didn't usually simplify unless it made the problem a lot easier to read. So most of the time in your calc classes, you won't have to simplify unless it states in the problem to do that. So I tried to do the same in this video. So to start, let's begin with the power rule. So the power rule relates to functions that are power functions, and usually power functions are in the form of like y is equal to n times x to the a, where n and a are both constants. And the derivative of this function would be dy over dx, or the derivative is equal to a times n times x to the a minus 1 power. So some examples of this are y is equal to 4x squared, then dy over dx would be equal to 8x. And if you had a function like 1 over 100 times x to the negative 100 power, then the derivative of this would be negative x to the negative 101 power. All right, so the next derivative rule we're going to talk about is the exponential rule. And the exponential rule usually has a base function of y is equal to n times a to the x, where again, n and a are constants, but this time the derivative will be dy over dx is equal to n times the natural log of a times a to the x power. So slightly different form when you rearrange the a and the x going from a power function to a exponential function. So some examples of this would be if you had a function like 3 times 2 to the x power, then the derivative of that function will be 3 times the natural log of 2 times 2 to the x power. Another common function you might have is when the base is e, so a function like 9 times e to the x, the derivative of that function will just be 9 times e to the x. Another derivative rule that intro calc students should learn is the logarithm rule. So if you have a base function y is equal to n times log base b of x, then the derivative of this function will be dy over dx is equal to n over the natural log of b times x. So to run through some examples, if we have a function 8 log base 3 of x, then the derivative will be 8 over the natural log of 3 times x. And if we had something like 2 times log base e of x, or 2 times the natural log of x, then you're going to end up with 2 over x, because the natural log of e is just 1. The next rule we're going to talk about is the product rule. So if we have two functions being multiplied together, then the base form would look something like y is equal to b of x times c of x, where b of x and c of x are two functions. And the derivative of this would be dy over dx is equal to b of x times c prime of x plus c of x times b prime of x, where the primes are showing the first derivatives, or just the base derivative of each function. So an example of this would be 2x squared times the sine of x. The derivative of this function would be 2x squared times the cosine of x plus the sine of x times 4x. Another example would be 5x to the fourth times e to the x. Your derivative is going to end up being 5x to the fourth times e to the x plus e to the x times 20x cubed. After this, let's talk about the quotient rule. So the quotient rule is similar to the product rule, except instead of the product of two functions, it's going to be the quotient. So you're going to have y is equal to b of x divided by c of x. And the derivative of this function would be dy over dx is equal to c of x times b prime of x minus b of x times c prime of x, all divided by c of x squared. So even though the only difference you're going to be doing between the product and the quotient functions is just what operation you're using, it's going to end up being completely different derivatives. So make sure you know which one you're doing. So let's run through some examples. To start, we have the sine of x divided by x squared. Our derivative is going to end up being x squared times the cosine of x minus the sine of x times 2x, all divided by x to the fourth. Another example would be e to the x divided by the sine of x. So our derivative is going to end up being the sine of x times e to the x minus e to the x times cosine of x, all divided by the sine squared of x, or the sine of x squared, however you want to put it. And finally, the last rule that you should know as an intro to calc student would be the chain rule. So the chain rule is when you have a function within a function, or a composite function as some people might call it. So the base form will look like y is equal to b of c of x, and the derivative of this function will be dy over dx is equal to b prime of c of x times c prime of x. So in the b function, your input will be c of x, but in the c function, your input will be x. Now, let's run through some examples. So the first function we'll have is the sine of 2x. So the derivative of this function will be cosine of 2x times 2. Another example, if we have e to the x cubed, then our derivative is going to end up being e to the x cubed times 3x squared. Now that we have a grasp for the basic derivative rules we'll have to know for intro to calc classes, let's try a challenge problem. So it's one that I created myself, and I ran through it a couple of times to make sure that the answer is right, but let me know in the comments if you got something else or you have a question about it, so feel free to let me know. So let's say we have a function y is equal to the log base 5 of the sine of x squared times e to the 3x, all divided by the natural log of x. So this is a very complicated function, but it incorporates all of the different types of derivative rules that we talked about. It has the log rule, it has the sine rule, it has the power rule, it has the exponential rule, it has the chain rule, and it has the product and quotient rules. So it's a very difficult and complicated problem, most likely more complicated than you'll have to know for your intro to calc classes, unless it's like a bonus type problem. But it's a good way to incorporate the challenges that you might see in a calc class, even in upper level calc classes where you have to use some more difficult types of derivations, really. So the derivative of this function is x times e to the 3x times the natural log of x times 3x plus 2 minus 1 divided by the natural log of 5 times the natural log squared of x times the tangent of x squared times e to the 3x divided by the natural log of x. So looking at these two functions, clearly these are very difficult to look at. I mean, I tried to color code as best as I could, but even with the color coding, it doesn't really look like much. But let's try and pick apart different parts of the derivative that we can see coming from our base problem. And I'll be doing a whole video on how to actually solve the challenge problem. It'll probably be my next or the one after my next video, so stay tuned for that. So one thing that should really stick out to you on the derivative is the natural log of 5. That should make a little bit of sense just coming from the fact that the derivative of log base 5 of something is 1 over the natural log of 5. So even if you didn't get this answer, it's a good way to try and identify, oh, okay, I know where this part came from. So that so keep that in mind, and it'll really help you in analyzing calc problems like this, because you'll be able to recognize what is the right answer, because this could come up in a multiple choice answer, maybe a little more concise, but still something like this. Another thing that you might notice is the natural log squared of x. So even though it's inside the sign of the whole thing, there is still a natural log squared of x. And that comes from the quotient rule being used on the inside of the sign of x, or the sign of that whole thing. So even if you didn't get the right answer, identifying where the natural log squared of x comes from can be a useful tool as well. Something else that you might have recognized is the e to the 3x on the very outside of the numerator. There is an x term there as well, but what we're really looking at is the e to the 3x part. The derivative of e to the something is itself times the derivative of that something. So you can see that it still kind of retains its properties. So by pulling it out, you can really see um, that there is still some sort of impact with that e to the 3x. And finally, the derivative of the sine of something is the cosine of that something, and then times the derivative of that something. But what we have is the tangent. So even though the derivative of the sine is not the tangent, you can kind of see the relationships because the insides are still the same. So somewhere along the lines between going from our base function to our derivative function, we can create, or we can simplify to create a tangent. All right, well, thank you guys for watching. I hope that this video was helpful. I know that review type videos can be a little more helpful than proof type videos. So at the end of each, I guess, phase of my videos, I'll try and do a review video where I go through the culmination of everything that I've gone over and try to make it more relevant for calc classes. Be sure to let me know in the comments what you want to see in future videos, and definitely let me know if you prefer review type videos over proof type videos, because then I can try and incorporate that more in my channel. And until then, I'll see you in the next video.